Hello, Stat 200, and welcome to Lesson 1. I'm Dr. Zimmerman, and I coordinate the instructional materials that are used across all of the online sections of Stat 200. I also make the weekly overview videos. These videos are meant to give you a relatively quick introduction to the week's lesson by highlighting the key topics and suggesting relevant strategies. This week you'll be covering Lesson 1, which corresponds to Chapter 1 in the Lock 5 textbook. Let's start by looking at this week's key topics. This week is full of vocabulary. This is different from most of the later lessons, which will include more procedures. I have just selected a few concepts here that I would like to review with you, because these will all come up over and over again in later lessons. This is by no means an exhaustive list of all of the terms that you're responsible for this week. Before we review these terms, I have some suggested strategies for this week. This week is special because it focuses on vocabulary terms. Some of the strategies that work well in this lesson will not work as well in later lessons that involve more procedures. First, you should always be reading the online notes and textbook. This is where all of the material that you are responsible for learning is located. The overview videos will just give you quick introductions and do not cover all of the required content. Ask questions on the discussion boards. Ask lots of questions and don't be afraid to jump in and help answer some of your classmates' questions or to ask follow-up questions. With all of the vocabulary terms this week, you may want to make flashcards. This strategy won't be relevant in most other lessons, but this week it may be a good idea to get some index cards and to make yourself some old-fashioned flashcards to practice your vocabulary terms. Study the relations between terms. Once you know all of your definitions, try organizing your flashcards in a meaningful way. See if your organization matches how they're presented in the online notes or textbook. And the last strategy, complete the optional practice problems in Wiley+. Each week, in addition to the required homework assignment, there is a practice assignment. These tend to be long, so don't feel like you have to answer all of the questions. You might want to just stick to the sections that you feel less comfortable with. Now, let's start looking at some of this week's vocabulary terms. First, variable. This is a characteristic that is measured and can take on different values. In other words, it's something that varies. The research studies that we'll look at this semester could have one variable or multiple variables. Variables may be classified as categorical or quantitative. It is important that you can correctly classify variables as categorical or quantitative because the variable type impacts the graphs that you can make and the analyses that you should perform. Categorical variables have groupings, in other words, categories. They have no meaningful order of magnitudes or a meaningful order with unequal intervals, such as rankings. These are also known as qualitative variables. Quantitative variables have numerical values with consistent intervals. They're also known as numeric or interval ratio level variables. Here are some common examples that you may see in this course. For categorical variables, biological sex, undergraduate versus graduate student status, academic major, and baseball team ranking. The rankings often trip students up because they do have numeric values, but remember that they don't have equal intervals. The difference between the first and second place teams is not necessarily the same as the difference between the 11th and 12th place teams. For quantitative variables, height in inches and weight in pounds are most common. Exam scores are quantitative if they're the numeric scores. Letter grades like A and A- would be categorical because they don't have equal intervals. And number of games won by a team would be quantitative. Variables can also be classified as explanatory and response variables. The explanatory variable is also sometimes referred to as the independent variable or predictor variable. The response variable is also known as the dependent variable. The explanatory variable predicts or explains variation in the response variable. Not all studies will have an explanatory and a response variable. Sometimes in observational studies, we're just looking at the relationship between two variables with no question about one causing or leading to the other. But in cases when one variable is predicting or explaining variation in another, the explanatory predicts the response. Statistical inference is what we're going to focus on in lessons 4 through 12. The purpose of statistical inference is to take information from a sample to make an inference about a population. In this picture, we have a population. This is all of the individuals in the group that we're interested in learning more about. Oftentimes, the population is large and we don't have the time or resources to collect data from everyone, or it may just be impossible to reach everyone. In those cases, we take a sample from the population, preferably using random sampling methods, which we'll learn more about this week. A sample is a subset of the population from which we collect data. Data from that sample is then used to make an inference about the population. In this course, we'll use inferential statistics to estimate population values or to determine if some difference exists in the population. The last topic that I'm going to cover here is the difference between independent and paired samples. Independent samples are completely different groups that are in no way matched or paired with one another. So these are two groups, or more than two groups, that are unrelated. In contrast, paired samples are related groups where each observation in group A is paired with an observation in group B. Oftentimes, these paired samples are actually the same people or the same object. For example, I could compare students' midterm exam scores to their final exam scores. In that case, I would have every student's midterm and final exam, and the scores would be matched by student. It is possible that these could be different people that are matched in some way. For example, we could have pairs of twin siblings, husband and wife pairs, or pairs of best friends. It is important that you can identify samples as being independent or paired because this will impact how analyses are performed. This concludes the Lesson 1 overview video. If you have any questions this week, you should post them to the Lesson 1 discussion board in Canvas.